All right, so section 3.4 is going to be all about regression equations and correlation. So the first thing we're going to do is look at some data and draw a scatter plot. So it says below is some recent research about fuel engine sizes. This data shows the engine size and the fuel economy of a range of gasoline cars. So we have our engine size in cc's and we have our fuel economy in mpg. So you can see over here on our graph, we already have the engine size on the x-axis, and that's marked out by 0.25. And then we have the fuel economy in mpg on our y-axis. All right, so the only thing we need to do before we can start plotting points is to mark out our scale on our y-axis as well. So for that, I just want to look at whatever my biggest number is, which is the 42.3. So let's see how many tick marks I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks. All right, so I think we should be good to count by fours here. That puts 40 at the top, but we do still have some more room on our grid that I can get up to the 40.3, so that's okay. All right, so with most of these points, they're not going to fall right on the grid line, so you're going to have to estimate on some of them, and that's okay. All right, so our first point, we have 1 and 42.3. So I'm going to go find x equals 1 on my horizontal axis, and then I'm going to go up to a y equals 42.3, so that'd be right around there maybe. And I'm going to plot my point. All right, next we have 1.1 and 37.6. So 1.1 would fall somewhere in between 1 and 1.25, and our 37.6 would fall somewhere in here between 36 and 40. So again, just estimate the best you can about where you think that would fall. Maybe around there. All right, then we have 1.2, and oops, I think I just put that in the wrong spot, didn't I? It's supposed to be over here. Oh, they're playing tricks on me. All right, then we have 1.2 and 32.9, around there-ish. 1.3, 37.6. 1.4 and 30.6, 1.6, 28.2, 1.7, 29.4, 2, 28.2, 3, I'm jumping out to 3 now, and I'm at 25.9, around there, and then 3.5, 20.7, and 4, 15.3. Okay, there we go. All right, so we can see that, there are some fluctuations within the data. Sometimes it goes down and then back up again and then back down again. But for the most part, we could say that as the engine size increases, the fuel economy of the car tends to go down. So for this next question, describe in your own words the relationship between the engine size and the fuel economy. We can say as the engine size increases, the fuel economy tends to go down. Okay, notice I said that word tends to go down because as we saw, again, there are some little fluctuations. Occasionally it does go up, but as an overall trend, the data goes down, or the fuel economy goes down as the engine size goes up. Okay. All right, so the next thing we wanted to do here is have our calculator determine the linear regression or the best fit linear model. So for that, I'm going to go ahead with this guy. I was having some problems with my graphing calculator app on this one, so I just did it ahead of time. Oops, spoilers, it's the end of my video. All right, so I went ahead and just did it ahead of time with my computer before jumping in here. All right, so what we're going to do here, right, is we're going to take all of this data that we have over here, so the engine size and the fuel economy, we're going to put it in our calculator, and then we're going to tell it to find a line of best fit. So what I'm going to do to start with is I'm going to hit my stat button, and then I'm going to hit enter on edit. Now, as a general rule, you want to put your X values in L1, which would be our engine size in this case, and you want to put your Y values in L2, which would be our fuel economy. Now, my lists are already clear, but in case you guys have anything in your list from a previous problem, you're just going to put your little cursor up on L1, hit clear, and then enter, and then put your cursor on L2, hit clear, and enter, okay? All right, so then we just need to put that data in there. So like I said, I'm going to type in all of my values for the engine size in my L1, and then I'm going to go over and type in all of my values for the fuel economy in L2. Okay, let's type those in. I type all those in, and I arrow over and just start typing in the fuel economy for you guys by making you watch this whole thing here. I'll jump ahead a little bit. Okay, so there's all my data in there. I'm looking back through. Okay, all right, so once you get all that data in there, then our goal is going to be to calculate an equation. So what I did is I went back to my stat button, but this time, instead of doing the edit, because we already edited our lists, we want to calculate an equation. So I'm going to arrow over to calc, and I'm going to go down to number 4, the lin reg, with the ax plus b in parentheses. Okay, now from here, you just need to hit enter, and your calculator will give you the a and the b for your model. Now, if you have one of the newer operating systems like I do, you're going to get this list view, and all you guys need to do is just arrow down, so your little cursor's on top of calculate, and then hit enter. So you can see that's what I did. I just went down to calculate, and then hit enter. Okay, so then it gives us our model here. So when we're using that lin reg, the y equals ax plus b, the a in this case is the slope of the line, and the b is the y-intercept. So let's go ahead and just jot this equation down on our paper. All right, and I'll just go out to 4 decimal places. So we'd have y is equal to negative 6.8276x, and then plus 43.41, let's see, we have a 295, so that'd be a 30. Okay. All right, now notice the question, it also said clearly define the variables and interpret the slope. So my variables are x was the engine size in cc, and the y was the fuel economy in mpg. All right, and then the last thing it asks us to do here is interpret the slope. So the slope of our line is the negative 6.8276, okay? And basically, when you're thinking about slope, you always want to think about it as a rate of change. And slope, remember, is a measurement of y over x. Okay, so in general, let me just put, where can I put a note about this? Let's put it right here. So slope is the change in y over the change in x. So in this case, you're thinking fuel economy in MPG over the engine size in CC, okay? So first of all, notice that our slope is negative, which means that it's a decrease. So what we would say is that the fuel economy is decreasing by 6.8276 for every one increase of the CC in the engine size. So I would say the fuel economy is decreasing by 6.8276. Okay, and I didn't have to put the negative on here because I said the word decreasing. That means the same thing. Right, and this is MPG for every 1 cc increase in engine size. Okay, which is basically the same thing that we set up here. As the engine size increases, the fuel economy tends to go down. Well, the only thing that we've added is how much it goes down by, right? The fuel economy is decreasing by 6.8276 NPG for every 1 cc increase in the engine size. So we're just being a little bit more specific than we were on this last part because we know specific numbers now, okay? All right. So the next part says, use your model to determine the engine size of a car that gets 40 mpg. So our fuel economy is the y, so we're going to plug 40 in for y and solve for x. So we would have 40 is equal to negative 6.8276x plus 43.4130. All right, so if we want to solve this for x, we're going to start by subtracting the 43.413 from both sides of our equation. So 40 minus 43.413 gives me negative 3.413 is equal to negative 6.8276x. And then just divide both sides of our equation by negative 6.8276. And we get about 0.5. So our x would equal 0.5 cc's. Okay. All right, I don't know if that's cubic centimeters. I don't know enough about cars, and it didn't really specify up here, so I'm just sticking with cc's because 1 cubic centimeter or 0.5 cubic centimeters for an engine size doesn't make sense to me, so I'm just sticking with cc's. Okay. All right, so then it says for this last part, a car manufacturer produces a new car with a 1.8 liter engine and a fuel efficiency of 40 miles per gallon. Plot this car's performance on the scatter plot, and if you were interested in buying a new car that was fuel efficient with this size engine, would you buy this car? Okay, so I'm gonna assume that our 1.8 liters corresponds to 1.8 cc's. I'm pretty sure. Okay, so I'm going to plot this as 1.8 cc's and 40 miles per gallon. Let's see if that seems to make sense. So 1.8 and 40 would be up here. All right, so that definitely looks better than most of our other cars, right? So for everything else in that range around there, we had the 1.7 had 29 mpg, 2 had 28 mpg, so this is performing a lot better than the other cars with a similar engine size, but has a much higher fuel economy. So to me, that seems like a great compromise. You're still getting a good engine size, so you're going to have that power behind your car, but not compromising on fuel efficiency. So I would say, yeah, I would buy this car.